All right, the next three examples, we are going to look at evaluating functions. So in example 1, we are given an equation, and we are asked to evaluate f of 2, f of 4a, and f of x plus 2. So in some cases it's a constant, in some cases it's an expression, but I am being asked to basically plug in these values for x. So as I want to solve f of 2, I would grab this equation, x squared plus 7, and instead of the x, I'm going to put parentheses, and I'm going to plug in for x whatever the input value they're wanting me to evaluate for. So I'd end up with 4 plus 7 or 11. So f of 2 equals 11, which means if I plug in 2 for x, I'm going to get out y, 11 for y. B and C are the same. I would encourage you to pause and do them on your own. This time my input value is 4a. And when I square that, I'd get 16a squared plus 7. There are no like terms. That is just my simplified answer. And then the last one, x squared plus 7 is my equation. I'm going to plug in x plus 2 for x. I do have to FOIL or square x plus 2, x squared plus 4x plus 4. Hopefully you know the pattern so you don't have to actually FOIL that all out. And this time I do have a few like terms, so I will simplify and get that trinomial. In example 2, I'm doing the same thing, but from a graph. I don't have the equation for this particular graph, so I'm just going to use the actual graph to evaluate. I know, again, I want to find what f of -1 is. That means x equals -1. I need to know what y value corresponds to that. So on my graph, I go over to -1 and find what the function, where the function exists and what the y value that corresponds, and it looks like it's -2. Now notice B says estimate the value of f of 2. So again, I'm looking at where x equals 2, what does y equal? So as I go to 2 and then up to the function, I notice it doesn't hit at an exact point. That's why it says estimate. I'm going to have to just give my best guess. I'm somewhere between 2 and 3. I'm pretty darn close to 3. So I would say this is approximately 2.8 would be my guess. And then C, notice this time I don't know the input value, I know the output value. I know what y equals, so I'm doing the same thing just off of the y-axis. When y is 2, it looks like there are actually 2 values this time, right? There's one here at where x equals 1, and there's another at x equals -3. And then D, estimate. So that tells me it's not going to be an exact value. Estimate where f of x equals 0. So y equals 0 here and here. And the x values that correspond are approximately, I don't know, is that about 0.3? It's definitely less than half. And -2.5. Again, it's an approximate guess about what that is. And then the last question asks me about domain and range. So we're going to talk more specifically about domain and range later, but finding domain and range off of a graph is actually, in my opinion, easier than finding the domain and range from a function. Basically what I'm doing, remember the domain are all possible x values. So I'm focusing on my x-axis here, and I'm imagining that I'm rolling my pencil. I take my pencil, place it on the x-axis down here at the negative side, right? Here's my pencil, and I'm going to roll it across the graph, and the moment I encounter my function, that is the first element of the domain. So right here is when I first encounter it as I roll my pencil across the page from left to right. That looks like -3, and I do hit it at -3, so I put a bracket, and I'm staying on my function as I go through, and then I stop. The function stop. My pencil is no longer on the function once I roll it past, is that +3? 1, 2, 3. Yep. So that would be my domain. This function exists for x values from -3 to +3, And then to do my range, I do the same thing, but now I'm rolling my pencil. I lay my pencil horizontally on the page and I roll it up the y-axis. So as I imagine doing that, I take my pencil and roll. I first encounter the function right here at this value. If like an alarm went off on my pencil as I hit it, that would start right there at -2. Oops, I connected the wrong thing. The range would be -2, and it does hit the function at -2, so I put a bracket, and then as I slide up, I'm still on the function in the last place. I know I come off the function on the left side right here, but the function still exists up here. So if this alarm was going off while my pencil was touching the function, it would continue to go off until I hit right there would be the boundary point where once I rolled past, is that 1, 2, 3, +3? Once I rolled past 3, the alarm would go off, right? So that would be my range. The last example is what we call a piecewise function. It's a function in pieces. It's one equation for a certain domain, and then it's something different for a different domain, a different part of the different values for x. So it looks like on this one, for anything 0, negative up to 0, I'm going to use 1 minus x squared, and for anything that's greater than 0, any positive values are going to go into 2x plus 1. So I'm being asked to evaluate a couple of positions. One is the first one, f of -2. Well, I have to consider which of these two functions I'm going to plug into. -2 definitely falls in this domain, right? That is a number that is less than or equal to 0. So f of -2, I'm going to plug into 1 minus x squared, where x is that -2, and then simplify. So f of -2 is -3. Now my second problem that I'm solving, f of 1, I have to consider which of these two functions I would plug that in for. And since 1 is a number that's greater than 0, I'm going to plug f of 1 into 2x plus 1, where the x value is 1, and I get, +3. I was thinking ahead. So f of 1 equals +3. Now I'm being asked to state my domain and range of this piecewise function. You will have homework questions that ask you for this. So it's going to get easier to talk about when we get to the domain and range part of the notes. But remember, your domain is all possible x values, and I have an explicitly stated domain right here. I can see this function exists for all values less than or equal to 0, and exists for all values greater than 0, and that covers everything, right? There's nothing missing. So my domain is definitely -infinity to +infinity, or all real numbers. My range is a little bit harder to talk about. I'm trying to consider all possible y values, and that's a little bit difficult to talk about without looking at the graph, and we haven't reviewed graphs of functions yet. So you may or may not really relate. Maybe this will hopefully seem somewhat familiar to you, but we'll get more in depth later on. But I'm going to go ahead and talk about it now since we're here. So I know for this part from 0, negative, though this domain, this is my function that I'm looking at. So if you remember x squared functions, that's a parabola. I see that the leading coefficient is negative, so it means it's going to be an upside down parabola. And this one is telling you the vertex has been shifted up 1 because it's +1. So my function would look like this. I would start here. It's upside down parabola, right? That's what that top one would be. However, I'm only looking at x values less than or equal to 0. So this part of my function is not really part of my graph, right? I'm going to start here, and it does equal 0, so it would be a closed circle, and then it's going to continue to go to the left and down forever. Now, for values that are greater than 0, that would be this part of my graph, right? I use this function. That is a line. It looks like my y-intercept is at +1, so I'm here. It is an open circle. It doesn't equal it, but the function is already colored in there, so I would include that. And then I go up 2 over 1, up 2 over 1, and I'm going to get this line that goes up and to the right forever. So there you can see the domain clearly. If it goes to the left and to the right, -infinity to +infinity, never going to stop. And I can see clearly that my range is the same. It goes down forever, up forever, -infinity to +infinity would be my range. Without the graph, that's a little bit more tricky to tell with piecewise functions. It's hard to picture all of that in my head at one time. I like to sketch the graphs. All right, we're going to talk about combining functions next.